Cool. So tell me, what were you looking for in an amino acid in that case? A charge. Okay. Did it matter which one? Could it be plus or minus, or did it matter? You were looking for a plus. Okay. On the side chain or the backbone? Amen. Side chain. That's right. So, sorry. Sometimes I get carried away. All right. So, what amino acid did you pick? Pardon? Yes, arginine. All right. That's excellent. Thank you. All right. We are on a roll today. So arginine. All right. Are there any other candidates out there? Lysine is another good one. Any others? All of them have pluses, but all of them have plus charges on them. Why don't you pick just any amino acid? Because that's the backbone, right? You have to look on the side chain. All right. So that's cool. All right. So arginine or lysine, they have a plus side chain. All right. Now, are they guaranteed to work? I got a yes. I got some no's. It turns out no, because are they exactly the same shape as histidine? They're not exactly the same shape, so it might matter. It might not, but it might. Okay. All right. Questions about that? Yeah. So what you mentioned was proline. Proline's a weird one. Its backbone is actually folded back on itself. So technically its backbone isn't charged because, its side chain is folded back onto the backbone. So that N plus is actually part of the backbone, it turns out in proline. So there's no charge on proline side chain, right? Right? Yeah. What do the numbers mean? Again, the 94th amino acid is aspartic acid. So like first amino acid is number 1, second 2, third 3, etc. All right. Let me do another example. Here we go. All right. Here's another example, holding pieces together. Again, we zoom in. See if I can do this right. What you got, this is a different red and green part. And if you look at today's information-packed handout, there's a little diagram of a hydrogen bond that forms between this side chain, which is tyrosine. Now, there's a hydrogen bond. Where on earth is the hydrogen? Remember, this doesn't show hydrogens. It's somewhere in the middle. All right? So my question to you is an analogous one. Right? What we've got here is, for this next one, we have tyrosine 144 makes H bond. Actually, interestingly, to valine 98's backbone, which is a little odd, but it's legit. It's a legitimate hydrogen bond. So what I want to know is another amino acid that could substitute for tyrosine 144 in this H bond. All right? So same deal. But except I'm looking to make a hydrogen bond. So, and what I'll do the same deal for Fidelkis is ask, what were you looking for, and then which one did you find? There's actually a lot more candidates for this one. But so think about it, talk to your neighbor, pick out a good one, and we'll talk about the details.